Have you ever wondered what might happen if a massive solar storm hit Earth in 2024? Well, you're not alone. Lately, the sun has been putting on quite a show, with a recent flurry of activity that has caught the attention of NASA and other space agencies around the world. In late 2023, a powerful solar flare, classified as an X5 class flare, erupted from the sun. This was the most potent flare we've seen since 2017, and it sent a geomagnetic storm hurtling towards Earth. Now, as we start 2024, there's a buzz in the scientific community about the possibility of a massive solar storm hitting our planet this year. But what exactly is a solar storm, and why should we be concerned? In essence, a solar storm is a massive burst of solar wind and magnetic fields that are flung into space, which can disrupt Earth's magnetic field and cause a variety of effects. These range from beautiful displays of the northern lights to potentially disrupting satellites, communication equipment, and even our power grids. Historically, the sun operates on an 11-year cycle, known as the solar cycle, during which its activity fluctuates from quiet to stormy. We're currently in solar cycle 25, which began in 2019 and is nearing its peak. This peak, or solar maximum, is often associated with an increase in the number and intensity of solar flares and geomagnetic storms. So, could a massive solar storm hit Earth in 2024? It's certainly a possibility. As the sun continues to approach its solar maximum, we could see more frequent and intense solar activity. However, predicting the exact timing and intensity of these events is a complex task, even for the most experienced scientists. As we dive deeper into this topic, let's first understand what solar flares and solar storms are. Solar flares and solar storms are fascinating phenomena that occur in our solar system, but what exactly are they? Let's dive in. Solar flares are sudden, powerful bursts of energy that are emitted from the sun's surface. These flares are the result of a process called magnetic reconnection. This is when the magnetic field lines in the sun's atmosphere tangle, cross, and then reconfigure, releasing energy in the form of a solar flare. The energy released by a solar flare can be equivalent to millions of atomic bombs exploding at the same time. On the other hand, solar storms, also known as geomagnetic storms, are a natural hazard that occurs due to these solar flares. When the sun releases a solar flare, it can also unleash a stream of charged particles known as a coronal mass ejection, or CME. These CMEs travel through space and can interact with Earth's magnetic field, causing a solar storm. Now, you may be wondering, what causes these solar flares and solar storms? The answer lies in the sun's magnetic field. The sun's magnetic field is always changing and reorganizing itself. Over an 11-year cycle known as the solar cycle, the sun's magnetic activity increases and decreases. When the sun's magnetic activity is at its peak, we see more solar flares and solar storms. So how do we detect these solar flares and solar storms? NASA's Solar Dynamics Observatory and other space observatories continuously monitor the sun. They observe changes in the sun's activity, including solar flares and solar storms, and provide valuable data that helps scientists predict when these events might occur. Now that we have a better understanding of these phenomena, let's explore their potential effects on Earth. Solar storms might seem like distant events, but they can have very real effects here on Earth. Imagine this. You're going about your day when suddenly the power goes out. Your phone loses signal, the internet is down, and even your GPS stops working. This isn't a typical power outage, it's the result of a massive solar storm. Solar storms are essentially eruptions of energy from the sun, and when they head our way, they can disrupt our power grids. This can lead to widespread blackouts, as the surge of energy from the storm can overload our electrical systems. In severe cases, this could take weeks or even months to repair. But it's not just our power that's at risk. Solar storms can also disrupt communication systems. The charged particles from the storm can interfere with the signals for radios, televisions, and telephones. Even our satellites aren't safe. These storms can damage their electronic systems, potentially causing them to malfunction or even fail entirely. And if you're an astronaut, a solar storm could be life-threatening. The radiation from these storms is much more intense in space, outside of the protection of our planet's magnetic field. This could lead to increased radiation exposure for astronauts on space missions, which is why NASA and other space agencies closely monitor solar activity. But it's not all doom and gloom. Solar storms also have a more beautiful side. They're responsible for one of nature's most stunning displays, the auroras. When the charged particles from the storm interact with our planet's magnetic field, they create these breathtaking light displays. So, while a solar storm might cause some disruption, it could also give you the chance to see a spectacular light show. While the potential impacts of a solar storm are serious, it's also important to remember that our planet has weathered these storms before. We have systems in place to monitor solar activity and warn us of incoming storms, giving us time to prepare and protect our critical infrastructure. So while a solar storm in 2024 might bring some challenges, it's also a reminder of the incredible power and beauty of our sun. As we delve deeper into the potential effects of a massive solar storm, you might be wondering what measures are in place to protect our planet. And rightly so, as the potential repercussions of an intense solar storm are not to be taken lightly. Firstly, let's talk monitoring systems. NASA's Solar Dynamics Observatory, among other spacecraft, constantly keeps an eye on the sun and our space environment. This fleet studies everything from solar activity to the solar atmosphere and even the particles and magnetic fields in space surrounding Earth. These observations are crucial in predicting and preparing for solar storms. But what happens once a storm is detected? That's where emergency protocols come in. Depending on the severity of the predicted solar storm, various measures can be put into place. This can range from temporarily shutting down power grids to prevent damage, to altering the flight paths of aircraft to avoid communication disruption. Astronauts aboard the International Space Station can also take shelter in specific parts of the station, designed to protect them from increased radiation. In addition to these immediate measures, there are also longer-term technological safeguards. For instance, power grids and communication systems are often built with certain redundancies and safeguards to minimize potential damage from solar storms. But it's not just about reacting to solar storms. There's also a lot of ongoing research aimed at better understanding these solar events. For instance, NASA's Parker Solar Probe is on a mission to unlock the mysteries of the sun's corona and solar wind. These studies will not only help us better predict solar storms, but also develop more effective ways to mitigate their effects. While we cannot stop a solar storm from happening, we can take measures to protect ourselves and our planet. With continuous monitoring, rigorous protocols, technological safeguards and dedicated research, we are doing our best to shield our world from the sun's tempestuous moods. The more we learn about these solar storms, the better equipped we will be to face them head-on. We've learned a lot today about solar flares, solar storms and their potential effects on Earth. We've delved into the fascinating world of our sun, the fiery celestial body that, while providing life-sustaining light and warmth, can also unleash powerful storms that can disrupt our technological systems. We explored the possibility of a massive solar storm in 2024, an event that could have profound implications for our planet. These storms, triggered by intense solar flares, can potentially disrupt radio communications, electric power grids, navigation signals, and even pose risks to spacecraft and astronauts. We also discussed the solar cycle, a phenomenon driven by the sun's magnetic field that flips roughly every 11 years, affecting the amount of activity on the solar surface. During peak activity, our Earth and its satellites can be at risk, but these periods also bring about the beautiful spectacle of the auroras, those dazzling light shows in the sky. In the face of these potential challenges, we've shed light on the efforts being made to protect our planet. From NASA's constant monitoring of the sun and our space environment to the US government's official source for space weather forecasts, we're not facing these phenomena unprepared. Moreover, we've highlighted the importance of ongoing research in understanding these solar events. Missions like the Parker Solar Probe are unlocking the mysteries of the sun's corona and solar wind, helping us prepare for and mitigate the effects of solar storms. While the possibility of a massive solar storm in 2024 might seem daunting, remember that knowledge is power. By understanding these phenomena, we can better prepare and protect our planet.